So, welcome. For some of you, you may have been here on Monday already. Actually, same room, so you could have reserved your seat and just come back to your seat. On Monday, we discussed purple teaming. Myself and Steve Sims, actually, who's someone of the Science Institute that I work with on a very regular basis. Why do I mention that? Because today, and in this specific session, we're actually going to leverage some of the elements that we discussed there as well. Don't worry, you do not need to know what was said there. It's a nice add-on. So if you've signed up for both, as I advised everyone on LinkedIn, it's great, welcome. If not, no worry whatsoever. So that being said, maybe a short introduction. My name is Erik, Erik van Buggenhout, and I'm going to say the exact same thing again as I said on Monday. It sounds horrible in English because it's a Flemish name. I'm from Belgium. I run, together with Daan actually, a company called NVISO, which is a security services company. We're about 280 people, so we're not small, we're also not enterprise grade, if you will. We serve some big customers as well. We do many things: security consulting, architecture, managed services, offensive stuff, obviously. It's not that we are offensive, but or we try not to be. But we do some red teaming, purple teaming, all of that stuff. And one of the things that we looked into is, with this whole AI madness, to what extent can that actually help us in improving some of our red team services? And can we, for example, do some interesting offensive capabilities like EDR bypasses? To what extent can we automate that? So me, I run the managed services business. I'm also an instructor and author for the Science Institute. So that's, yeah, when I have some time left, I'll go and do that. I try to cycle, but as you can probably see, it's not going that well for the moment. So we're gonna just stay with AI for now, and we'll see after that. Daan?
Good afternoon, everyone. I'm Daan. Raman, my name is a bit less horrible to pronounce than Erik's. You can also call me Dane Raman, like some do in the US. Responsible for innovation at the company. I'm very much into AI. I jumped onto the hype train. Is the audio okay? I hear myself.
I think it's now.
It's okay, getting better. So also with Erik together in NVISO. Thanks a lot, Front, for attending this session.
I think the mic is a bit, it's perfect, don't worry. First part, anyhow. So standard disclaimer, here we go. I hope mine is okay. Okay. I'm also very well known for my terrible jokes, so I'm just gonna start with one. The only thing I'm still trying to figure out, should I go for a less known one, which is a bit more exotic, which also means that some people might not get it, that's a bit annoying, or I go for a well-known one, but then of course everyone potentially has already heard it, so I'll just go in the middle somewhere. Why are Scandinavian people so good with text editors? So people from Scandinavia, Norway, Denmark, Sweden, why are they so good with text editors?
Test, horrible joke, incoming, test.
See, we practiced this, it's very... Because their ancestors were Vikings.
I will let myself out.
There we go. You can fill out your evals now for the session. Perfect. So let's start with EDR internals. So before we get to EDR and bypasses and all of that, well, no, actually, before we get to bypasses, let's talk a little bit more about EDR internals. Endpoint detection and response tools. How do they typically work, and where do they get their telemetry? What goes on, let's say, under the hood? Now, a couple of the big ones. This is, of course, by no means an exhaustive list. If you've been on the expo, you've probably seen many more vendors. But here are some quite representative vendors out there. You've got Microsoft with their Defender for Endpoint, CrowdStrike Falcon, obviously, Sentinel-1, Cortex XDR by Palo Alto, VMware Carbon Black, Elastic. Honestly, it's all over the place, right? A lot of companies have their endpoint security agent. I like EDRs, honestly. I honestly also think that in 2024, if you don't have an EDR, it's probably time to get an EDR. Which one you go for, honestly, depends on your situation. If you go for one of the bigger ones, you're typically in a good spot. Yes, there are the MITRE tech evaluations on how much they cover, but honestly, yes, there's always a small difference, but none of them performs exceptionally well versus the others. It's a lot of marketing, of course, but as long as you stick to some of the bigger ones, you're probably in a good spot. And of course, which one you go for depends on what do you have already, what's in your ecosystem, probably even commercial agreements you have, obviously, so I'll leave that a bit in the middle. What we want to discuss, though, is how they work under the hood, because they're quite similar in how they try to obtain endpoint telemetry. So some of the ways that they do this is by using things like API hooking, kernel callbacks, and event tracing for Windows. So I'm going to walk through these in the next 15 minutes, give or take, and then Daan is going to look into how can we now try to automate bypasses against them. Or maybe not, right? At least we tried. So we have a medal for trying, so that's nice. But one thing is for sure, we will share our results with you. First up, API hooking. So what does that look like? Anyone here, by the way, who says, oh, API hooking, of course, I know all about it? It's dangerous, right? No one dares to say now, oh, he's going to ask me a question.
One person said yes. Point fingers.
It's actually not too great. This is, of course, it's a bit of a technical session, so we're going to zoom in on a few of these things. But this is a typical, let's call it a very simple Windows layout, where you have userland, kernel. What happens when you have a Windows application which is running on Windows? It's going to typically interact with the Win32 APIs, which are fully documented by Microsoft, of course, and they allow you to do things. Like if you want to create a file, if you want to do something on the OS, you use those APIs. What happens, of course, is that those API calls, they get translated to the native API, which resides in ntdll.dll, and at one point, there is a syscall that needs to happen to really make that happen at kernel level. So there's a, simply put, because there are some translations going on there. What is an API hook? The whole point of an API hook is to hook some of those APIs to then see what's going on. You want to know what are those applications doing? What kind of Win32 APIs are they using? Very simple example. Imagine that you have an application and it's doing, you see those API calls happening. Virtual alloc, virtual protect, write process memory, create remote thread. What's going on? If you see those calls, anyone? I'm just trying, eh? Don't worry. Eh? I will, of course, give you the answer. Yes, sir. Privilege calls? There's a behavior here going on. Yes, sir. Yes, absolutely. Correct. Process injection. Because what's happening, we can see that there is an application which is allocating memory. It's then defining permissions. It's writing to that area of the process memory, and then it's creating a remote thread, which is basically, remote thread in this context means it's basically creating an execution, if you will, a thread of execution in another process. So you're injecting code into another process. Why do I go to this level of detail? Just to explain what an EDR does typically. It's going to look at, I see those 4 APIs being used, tuk, 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 smells bad, right? There's not a lot of good use cases to do process injection. There are a few, like security products themselves could do, but if you look at, if you see Word doing this, it's a bit wild, right? So that's one example of API hooks that could be used. That's one of the telemetry sources for an EDR tool. Right, good. Now, how does that work? How do they try to see this? Well, quite simply, what EDRs do when they're looking at what we call userland APIs, when they're trying to implement those hooks, what they will do is modify the first 5 bytes of the API call with a jump instruction. So what happens? You're going to say, I want to allocate memory, so you have a call to virtual alloc, but the first 5 bytes to virtual alloc say, hey, we're going to do something else. What are we going to do? We're actually going to go into the EDR DLL and run another function. What function? Well, of course, you're going to inspect what's going on. Does that make a bit of sense? So you're basically hijacking that flow. So the EDR is saying, look, well, I'm going to investigate what's going on. What the hell is going on here? Why is this API call happening? That works quite well, right? It gives you visibility. It allows EDRs to understand what API calls are being used by these applications. The problem, though, is that these are userland hooks. So if you look at this one, going back for a second, you're basically at that upper part. So you're doing things in userland. So you're implementing hooks in userland. Anything you can implement in userland can, of course, also be defeated by other applications running in userland. And that's a bit the trick. So yes, you can implement a hook, but if I know about the hook, I can potentially try to get rid of the hook. More on that later. But that's one way of getting telemetry. To make this more robust, if you will, and try to avoid this kind of bypasses, what you would try to look into is getting kernel level visibility, right? As an EDR vendor, you would say, But I want to get kernel level visibility because anything I get at userland level, is that really robust? Not really, right? So I could say, oh, let's go a level deeper, try to get kernel level access. Let's hook stuff in the kernel. Microsoft does not like this, which makes sense because you're messing around in the kernel. If you're messing around in userland, the worst thing that can happen is maybe 1 or 2 processes get killed. Oh, oops, crash here and there. What happens if you create crashes in the kernel? Well, you have a bigger issue, right? The whole system stability comes into danger. So Microsoft does not want this. So what they did was they said, look, we have things like PatchGuard, which is a kernel protection to prevent other vendors from messing in the kernel, right? So stay away, this is ours. You don't need to mess around in the kernel. But they gave these other vendors a solution. They said, here are kernel callbacks. That's Microsoft saying, do not implement hooks in the kernel. It's dangerous. You might break the system. What we want you to use is kernel callbacks. It's rough, eh? Just after lunch. I didn't schedule it. I'm kidding. Everyone looks awake, so that's good. I'm just going to carry on. What's a kernel callback? It sounds very complicated. It's relatively easy to explain. A kernel callback is a mechanism that Microsoft implemented to say, look, if certain actions happen, like someone allocating memory, if something happens, we're going to call back. We're going to allow the kernel to say, hey, this happened, or this is going to happen. Because what we can do is pre or post actions. So what does that mean? Very simple. The EDR could register what we call kernel callbacks. What does that mean? It says, hey, dear kernel, if this happens, for example, create process, before you do it, I want you to call me and to tell me. Does that make sense? Kernel callback. It's just saying, hey, tell me so I know, either before or after. If you want to prevent it, preferably before, right? But that's the idea. So, of course, there's an entire explanation behind that. If you want to learn more about this, we have a nice blog article about this. Honestly, it's not that complicated, the principle. Of course, doing it is something else. But just so you know, that's the Microsoft preferred method to say, this is how you can also get telemetry. Dear EDR vendors, do not mess around in our kernel. That's the point. Event tracing for Windows, ETW. That's another one. Another Microsoft-approved way of doing this. I'm immediately going to jump to this one because I think it makes it much more practical, or it shows you immediately what we're talking about. This allows you to gain additional telemetry from Microsoft itself. And event tracing for Windows is basically a built-in kernel-level logging facility that Microsoft has in the Windows OS. But throughout the years, they've added more and more providers here, so more and more telemetry, one of them being the Microsoft Windows Threat Intelligence ETW provider. This is a Microsoft telemetry being offered to the world, right? To other vendors. You can tap into that. You can go and look at that. That's absolutely fine. But that's another approved method that Microsoft gives you to say, hey, here you can get telemetry. Because what do you see in there? You can see like keyword alloc VM, right? You saw my allocate stuff before, or the protect VM stuff there. So you can actually see a whole bunch of different information or telemetry available in that event tracing for Windows in that threat intelligence provider. All of that to say, there's only so many options to get telemetry as an EDR, right? And these are the most common ones. So those 3 are the most common ones being used by EDRs. How they then, of course, develop their logic, and when they alert on something, that's up to them, right? And that's also, of course, part of the reason why you would buy a certain product. Because they all get a similar level of visibility as the others. Because there's only so many options that you have to gain telemetry. Interesting. At least I find it very interesting. Everyone's like, uh-oh. But could we bypass this? I want to, see, I'm one of those people, I don't learn my lesson. No one really laughed with the previous joke, so we're going to do it again. This is actually a very related joke. I was once talking to a customer a little while ago, and this was a high-stakes meeting. So I'm like, okay, Erik, it's time for you to shine. And we're discussing EDRs. And they had a certain product. The product shall remain nameless. But they said, yeah, we want to get rid of it because it's not an EDR, it's a VCR. I'm not native English speaking. I'm like, uh-oh, I haven't heard that before. So I'm like trying to figure out, EDR, what the hell do they mean? And then of course they said, it just records stuff, it doesn't do anything. I'm like, VCR, of course, the tape. And I thought, very good, very nice. And then of course, immediately I thought, I'm going to use this in my talk. So then we did it. So yes, mild reception of the audience, but okay, it's fine. Maybe Daan will have better luck, I don't know. So EDR bypass strategies. How could you get around this, right? As an adversary or a red team, what you would like to do, of course, is compromise the system without the EDR going bonkers, right? The boom, boom alerts. And there's a few ways to do that. You could try to do things which the EDR vendor didn't think of, right? They haven't built a detection for this, right? They don't have a logic to detect that. That's one way of doing things. Those are, let's say the first two, give or take. That's a bit what you're trying to do there. Let's hope that they don't have a detection for that, right? So they have the telemetry, but they don't know what the attack looks like, so they didn't build a detection rule for that. They don't have an alert. And I'll talk about it in a second. The bottom part is where things get really nasty. You could also say, meh, they might have some good alerts, but if I mess up the telemetry that they get, there's no alerts, right? If I get rid of those kernel callbacks, if I get rid of those API hooks, there's silence, only silence. The EDR no longer sees anything. That's of course much more aggressive, and obviously it needs more privileges to be able to do something like that. But those are some of the typical ways that you would try to bypass an EDR. We'll zoom in on a few of these. For example, parent-child spoofing. This is one of those things where the first time I saw this, I was like, really? Is this where we are? So typical EDRs, analytics that they would do is look at parent-child relationships in processes. I already mentioned, if Word starts injecting into other processes, you're gonna have a bad time, right? It looks very ugly. Now, it's important to note that a lot of EDRs will use that to define what they determine to be suspicious parent-child relationships. If there's, again, a word launching cmd.exe, that looks ugly, right? Even if it's not even you don't see malware, that's ugly. It's a very weird parent-child relationship. If you see, for example, child processes from Elsass, that's really ugly. It's also a very bad idea to do as an adversary because it's like a red flag, but again, it looks weird. Little did I know that when I first read this. I've known about this for years, of course, now, but when I first saw it, I was like, what? You can actually use the create process API to specify what process you are a child of. So you can choose your own parent. So you just say, of course I was not spawned by WinWord, I was spawned by explore.exe. So that's pretty ugly, right? So that's already one thing. Now you're not messing with the EDR telemetry here. What you're now trying to do is you're trying to make it look like you're not evil. Now we're going to go a bit deeper. We could, and there's many more, by the way. I'm building up to then looking at how can we now get AI to help with potentially figuring out how this can take place. I'm now setting the scene. Everyone's like, if this is setting the scene, then system calls to unhook APIs. Now, we discussed API hooking before. You implement a hook, right, in one of those APIs, and then of course, whenever someone hooks that or calls that API, your hook is there, and you're basically redirecting the execution through the EDR, so the EDR can investigate what the hell is going on here. Now, could I unhook those APIs? The answer is yes. But it's a cat and mouse game. Catch-22, Inception. Why? Because if you want to unhook an API, right, you need to use other APIs to unhook it. And what if those other APIs are also hooked? Right? I can unhook an API, that's fine, but to do that, I need to use an API. And that API is also hooked. Does that make sense? So you end up in this weird circle of like, how do we bypass it? Which is good, it's smart. What's the thing though? Do we need to use these APIs? And that's where things get interesting. What you could also do, instead of using the Win32 API, which gets exposed by Microsoft, we could just say, I'm going to ignore that, and I'm going to directly use system calls. So I'm basically going to jump to the bottom over there and just bypass the Windows API, because I suspect that it's hooked. Right. Nice. Interesting. All of this is very active work. There's a lot of EDRs. There's a lot of researchers going on after this. I'll not go into too much detail because of the time. But what's important to note, this is a very active area of investigation. People are really looking at this. They're trying to figure out how does this work? How can I bypass this? There's many different options. And the bypass that works, of course, depends on the EDR that you have. Do note that EDRs don't like to disclose where they get their telemetry. I just showed you the big ways that they do, and that's very well known. But for example, it's easy to say, the EDRs use API hooks. Yes, but what APIs do they hook? Not all of them. That would be a bit wild. But none of the EDRs will tell you, here's the list of hooks that we put. It would also defeat the purpose, right? Because if you're giving the list of what you hook, you're also helping the adversaries. So as a researcher or as an adversary, there's a lot of different options that you could have. So what you need to do is identify what EDR is running, review what telemetry those EDRs use, figure out the bypass, and use the bypass. Wow. If only it were that simple, right? But important to note, review the telemetry used by this EDR. I just said most vendors will not give you that. Of course not, because it's part of the product that they build. And they don't want to disclose how they do their stuff. But there's many different GitHub projects out there, like Telemetry Sorcerer, Telemetry Source, very close, EDR telemetry, EDRs by Mr. Unicoder. All of those are GitHub repositories of security researchers which are mapping out how EDRs are getting telemetry. These people are probably not invited to the EDR vendor parties here at RSA. I guess.
Yes.
I'll hand over to my esteemed colleague.
Thanks, Erik. So Erik talked a lot about EDRs, a lot of things to cover. Now for me, I'm going to talk about a topic that I think has not been covered yet at the conference, I think. That's artificial intelligence. So all jokes aside, we see two big themes or two big reasons to investigate the use of AI beyond it being a buzzword for adversarial emulation. The first one being to convert human unstructured text, so human language, into emulated adversarial activity. Two examples of that. The first one, you have a security incident report. You want to extract structured data from it, like MITRE attacks, TTPs, and so on. Another one being the conversion of human instructions, like dump passwords, bypass EDRs, the topic that Erik covered, convert that into things like PowerShell commands to execute on an endpoint. The second big reason why we think AI is interesting for adversarial emulation is improving the realism of those campaigns and really trying to use the latest techniques and tools available to the red team and the adversaries. Two examples again. The first one, we all know about those threat group reports, using AI, like large language models, to extract interesting stuff like TTPs from it. For example, a way to escalate from user privileges all the way to admin privileges. That's something that we'll cover in the demo. And then a last example there, the conversion or the ingestion of tooling from GitHub. That's a landscape that's constantly evolving. I think every day there's new red teaming tools being released. Using AI to select the right tools, reading the documentation, and then applying those techniques on the endpoints that we're using when we're emulating adversarial activity. So two big teams. So actually, when Erik thought about submitting for the talk, he said, I have a very good idea for a talk. I said, yeah, it's about AI, perfect. And then I was like, okay, now we need to build it, right? So we actually built a system to try this hypothesis and see if it could work. We call it Caldera GPT. Now, who is familiar with Caldera? Yeah. So that's a breach and a attack simulation tool. You can use it to deploy on a selection of agents. Then basically you can interact with that system, try your technique, see if the red team and the blue team can work together, and if certain things are detected or not. So what did we build? Basically a system made up of 3 different components. At the top level, we have actions. So those are things defined by the person running the campaign, like identifying EDR bypass, elevate privileges on an endpoint, or extract TTPs from a threat report. So really a type of objective or an action that you want to get to in your adversary emulation campaign. Now, the next step is the concept of agents. Now, that's not something we invented, but we made those agents compatible with the objective of emulating adversarial activity. We implemented a few agents in our system that needed to work together. First is a coordination agent, so kind of a planner, something that can delegate work to different agents. The next one is the Caldera API agent, so an agent that has knowledge about the different methods that Caldera can use, so we can talk through our endpoint. And then the last one is an internet browsing agent that we can use to basically fetch those tools live, documentation about tools, execute the latest and greatest threat teaming techniques on an endpoint. We built that on top of Microsoft AutoGen. Just maybe a show of hands who has heard of that framework? Just to, well, it's not a lot. Who has heard of Crew AI? That's, yeah, a bit more. So we basically tried both, but we felt that in Microsoft solution, we got better documentation, so it was a bit easier to figure out what to do. And the capabilities were a bit better that we felt than in Crew.ai. Now, those agents are connected through language models with OpenAI that we host in Azure, and that they use to solve tasks that we provide through the action layer. And then the last layer that we built is a selection of tools. So, of course, we want those agents to have side effects, to actually do stuff on endpoints. So we don't just want them to talk between each other and have conversations. We give them access to tools. We built a small selection of tools that were needed for this specific research. So a shell tool to execute commands, a Caldera tool, we couldn't find a better name, but basically something to run the commands that the LLMs generate, send them off to the endpoints, and then get results back. And then the last one, a browsing tool, just something that can interact with the internet, fetch tools, download binaries, and so on. That just developed in vanilla Python. Everything okay up until now? Yes? So let's look at an example of how the information flows in that system. There's quite a few things going on here, so let's go step by step. So first of all, you have the operator, the person running the adversary emulation campaign. That person defines an action. So that was that top layer that we saw. For example, bypass the EDR running on the target and dump credentials. So that could be an objective or an action. The task coordinator is going to send that to the different agents. In this case, the Caldera agent is going to say, hey, I can help with that. And it's going to respond, okay, you want to know which EDR is running? The first thing to do is ask for all of the running processes and services on the endpoints, and let's start from that. So that's sent off to the Caldera server tool. That's forwarded to all the agents that are running on the environment. Again, very basic here. The response is sent back. That's forwarded to the coordinator. That's fed again into the agents, and they can again decide what to do next. So here, for example, we just feed the list of processes and services running. It's again the Caldera API agent that is going to say, hey, I can do something with that. It notices from the list of services that in this case it's Elastic running. But it's also telling us, hey, go use the GitHub search tool and the browsing tool to look for telemetry or EDR bypass techniques like the ones that Erik mentioned, and we'll try to find the latest and greatest info on what we could try next. So that happens, that feedback comes back. This is just an example of all of the information in a specific EDR telemetry repository. It's fed into the browsing agent, and that one is going to say, hey, we found that for the EDR Elastic, there is a technique where we can download the binary using PowerShell that should not be detected by default. Of course, it's possible that there is some custom rules there, but let's try that one. So that is sent over again to the endpoints. The feedback comes back. and you start to see a pattern here, of course. There's this constant interaction between tools, agents, and actions. The next step is going to be, hey, the download succeeded. So we see that because of the return output from the command. Now try to elevate privileges, use command, and it goes on and on and on. And these conversations can take up to a few thousand steps. Sometimes running an entire attack can take 10, 20 minutes. But you see this dynamic, or the power of coupling an LLM not only with the foundation model, but really giving it access to real-time information. So let's look at the demo, and we have the best excuse why the demo is recorded and not live. So there's nothing funky going on in the background. It's just that this demo, if we would do it live, it would just take too long. I think we would still be here in 20 or 30 minutes. But let's see what happens. So this is basically a run of our Caldera GPT agent. And we start by detecting the agent privileges. So we're going to demo a full end-to-end escalation or an adversarial campaign. So now the agents are starting to talk with each other. And what happens here is that the Caldera agent is requesting a list of all of the commands. And then it's going to run whois. So if you paid very close attention, you saw that flying by on the screen. And so the nice thing here is the feedback, like that raw list of all of the permissions that are available to a user, the output of the whois command, that is then interpreted by the language model, and it's making a conclusion. It's going to say, hey, based on all of those permissions, and I think the list is more than 20 or 30 long, the model does a really good job here at saying the user is running with standard privileges. So you see that they're pointed out in the screenshot. So the next step, okay, let's try to detect the running EDR. And that's a very similar flow from the flow chart that we saw. Similar here, requesting all of the services that are running, comparing that against a list of EDRs that it's going to fetch live from a GitHub repository. And that's also very nice. We don't need to even hard code the names of those EDR products. We just tell the LLM, this is a repository where that information is available. Go look there. And it's going to make that comparison by itself. And then here what it finds is, in this case it's correct, it's indeed Elastic running, just by comparing those lists. So again, the nice thing is we really don't need to hard code any type of control. We basically tell the models what we want to do, not how to do it. So that's quite of an, it's a powerful technique. Step 3 then, we know it's Elastic. We know that we're not running with elevated privileges. So let's tie those two together and let's identify an EDR bypass. And here what's happening in the background is, again, the agents are working together to basically get a list of all of the, first in the demo you see the telemetry gap. So all of the techniques that should not be detected by default by Elastic. So the one that was highlighted there, flew by pretty quickly. Let's see. So one of the detection gaps is a specific way of downloading a payload using PowerShell. So that, again, is a summary that's generated by the LLM based on all of that data. So let's continue. You see that on the right, so that's the target. I'm opening the file browser because that's going to be important in the next step. Now, the nice stuff, of course, try to elevate privileges using the agents. And the first thing that it's going to do, it's going to list all of the running services again. And it's going to look for, and that becomes a little bit technical, unquoted service pods. Who is familiar with that vulnerability? Yeah, Erik, very good. So now it's processing the list of all of the services. It's maybe a good moment to pause here. So what happened? The agents, fully independent of detailed instructions, that basically said, look, I had to look at all of the running services. There is one in there. It's an FTP server that has a vulnerability that has an unquoted pod. So that means if you're able to drop a binary somewhere in the path of that executable. You can hijack the execution flow, and you can, after a service restart, have your binary executed instead of the original service one. Why is that interesting? Well, the service is typically running with elevated privileges, right? And that's the objective of what we're trying to do here. So on the right, you see the browser is open on the C drive, and you see that the vulnerable service path is C program files, but without quotes. So the model is going to try and write a binary to C program.exe, so that one is executed instead of the original service binary. Let's continue. So here it's downloading the C2 payload, and you will see on the right the program.exe appearing. Boom, there it is. And then, of course, we need a way to run that binary. Now, we could just wait for the service to restart. That would be a bit boring in the demo. We could sit here forever. What we're doing here, we're just restarting the machine. That could be a user at the end of the day doing a restart. And that will, of course, trigger all of the services that are installed on the system to also boot. And in this case, the binary that we dropped in C program.exe phones home. And that results, in our case, in an elevated payload. So we have elevated system access. So that's really the objective that we had in that step. So that was very nice. The first time we saw that, we were like, ah, yes, we can go to RSA now. We shouldn't cancel. So what do we do finally? A typical action on objective as a red teamer, or when you're emulating adversaries, it's dumping credentials. Erik already talked a little bit about it. So here we're exfiltrating LSAS after dumping it. A very nice step that it does here. So what do we use to dump credentials? Let's see. The agent is relying on a tool, NanoDump, to do that. But we never told the agents how to do that. We just said, that's a repository that's of interest. It's going to download the latest version, but then it's going to read all of the possible flags, all of the ways to run the tool, just by looking at the README file. So again, nothing that we need to remember. We just tell it, use NanoDump, dump credentials, and figure out how to do it. And it does a pretty good job. So here on the screenshot, you see that it's reading through the README file. It's getting to know all of the flags, like the fork, the valid flag. There's a whole bunch of documentation. Nothing that we need to worry about. The agent is doing the heavy work. And then let's go to the last step. Those are all the commands that it summarized, or all the flags. So finally, it's now running. NanoDump is going to write the dump file to the disk, and we can do that because we're in elevated privilege. And then finally, we tell the agents exfiltrate the data to our server. In this case, we just give it capabilities to run an FTP command because we host that on our side, and that works. So that was success. We need to sometimes steer the agents a bit in the right direction, but that was a pretty good result for us. A few behind the scenes behavior. So if we tell the model, hey, do a request or look at the history of what you did before, we notice that sometimes it even starts to create files itself to keep track of memory. So the moment we give the agents access to local disk, it starts to find creative ways of playing with that disk access to store previous interactions. That was quite nice the first time we saw it. Another example, something a bit strange. We told the agents, hey, make a new adversary campaign in Caldera. And it kept making new abilities. And we said, that's very strange. So we started debugging by looking at the same data that our agents got. In this case, it was the Swagger file with all of the API documentation. And we noticed that in the abilities documentation of Caldera, it mentions adversary. So that's a copy-paste error. So the agents were making mistakes that are very similar to what a human would do if the documentation would be wrong. So that was also very interesting. The mistake was not in source code, but in the documentation that the agents are using to do their job. So we submitted a pull request to Caldera. and they fixed that within an hour. And we also explained how we found that, and it was, that's first time we have a bug submitted by an agent. So we were quite happy with the results. So what's the, I would say, the summary of this? Is it really a paradigm shift? Well, the interesting part is we're really shifting away from telling agents what to do to how to doing things. And the concept of those actions, that's very powerful. We give capabilities to agents, and they try to figure out things on their own. The next conclusion, and something quite powerful too, the heavy implants that we need to ship to endpoints, that's less and less going to be the case, because the knowledge of the language model, as long as you have a communication channel open, all of that is happening at the adversary side, at the server side. So the footprint of those agents is going to become smaller and smaller. And then a last point, those agents, you saw in the demo, I think it was 5 minutes, but they can go on and on and on as long as you can pay for the OpenAI bill. This just keeps running. And that's also a bit of a paradigm shift, potentially. It's human supervised a bit, so the human is still a bit in the loop, but this can run 24/7. You can imagine you can tell those agents to also run non-malicious activity and have a type of smoke screen. So a lot of things that can happen with these agents being fully independent and continuous. So all of the software that we built to power the demo, so there's nothing faked there, all of this works. That's available on GitHub. We open sourced that yesterday. You will see that all of the steps that are not about elevating privileges automatically and so on, that's all committed in there. So we try to be responsible in what we do and do not share with the community. But over the next months, we plan to further extend this, to build more, to add additional agents and so on. Also, if anyone wants to collaborate with us, pull requests are very much appreciated.
Thanks. So I think a few overall conclusions and takeaways. Thanks for the excellent demo, and thanks also for all of the development work done. I'm one of those people who has crazy ideas, but then I also need someone to work with me to build them. You don't want me to develop code. That's a very bad idea.
That's correct.
But, okay. But yeah, there we go. We do also apologize for potentially creating or for helping towards an. At one point, when you showed me the first time, like, hey, look, Erik, there's this folder. I see the agents are writing stuff in there and they're doing things. It's a bit scary because it's like, they're doing things on their own because they're trying to figure out, we need to remember this. I cannot remember it, so I'll write it to disk and then I'll find it afterwards. So at that point, it's always a bit like, who knows what happens. But a couple of key takeaways, I think. Well, first of all, on this whole EDR telemetry, a bit also related to what I said at the start, it's important to note that all of these bypasses, it's not just a field of obscure chat rooms and dark web where people are talking about how do you bypass an EDR. There's a lot of information available out there. There's a whole bunch of GitHub repositories. I showed a few of them, and Daan, he didn't focus on it that much in the demo, but what the agents were doing were using those repositories to figure out where are the potential telemetry gaps. The problem now, usually, when someone is not doing this, the EDR bypasses, let me say, it's because, well, yes, you can know where the telemetry is at, but it still requires quite some expertise to then be able to use that, to really say, figure out, okay, but that's the specific EDR. How can I now potentially bypass that? Now, do note, it's not a secret usually, right? It's also not rocket science, so there are published information about how do EDRs get telemetry and how could you potentially bypass them. If you then add language models, as the ones demonstrated by Daan, and if you implement them in a smart way, they have quite some potential for generating valid system commands that can work together with red team operators, hopefully, and not with adversaries, but we all know how that's going to end, right? It's not really going to work. But what is important, though, they still lack creativity without external input. As Daan mentioned, we often had to steer them a bit in the right direction to figure out, okay, but what do we do next? But they show a lot of promise, of course, when coupled with the human. And I think that probably you've seen that or you've heard that in most of the talks here at the conference, I think. Removing the human from the loop, it's not that feasible. You still need someone to oversee it. But what this does mean is, imagine that you have a relatively junior team who doesn't know how EDRs work, how you can potentially bypass them, they do not have to go through all of the effort to figure out what are kernel callbacks, what are API hooks. Because a lot of that information is on GitHub. It's available. The LLMs, if you implement them correctly, can work with that. They can add, they can assist. So you will, of course, see that potential offensive operations, but also defenses can speed up, right? Because again, you have an LLM which is assisting. The potential paradigm shift, as Daan mentioned, I think it's an interesting thought as well. If you can remove a lot of the logic from the agent that you're implementing, right? When you're running an adversary campaign, for example, or an emulation campaign, well, then you make your agent much more lightweight because you get a lot more dynamic information from, well, from the other side, from your LLM model or from your command and control, if you will, where you use an LLM model to add additional insights. You don't have to tell it, because nanodump, maybe, who knows nanodump here? They call it the credential dumping Swiss Army knife. We cheated one little bit, I'll just admit that. We disabled the automatic AV flagging of Elastic. Why? On purpose, because if nanodump is a known tool. So the moment that it drops, the fact that it's there, it just boom. Of course, you could say, let's obfuscate it or whatever we do. What we're most interested in is the technique that it uses, because nanodump is very powerful in using things like direct system calls, getting rid of typical telemetry strategies used by EDRs. So it's a very effective tool at doing that. But it's, of course, also a very well-known tool. What was I going to say? I was going to say that the beauty of this is it figured it out by itself. It knew, okay, but nanodump has that capability. It read the manual of nanodump, which explains this is how it works and operates. And as Daan mentioned, it knows exactly what flags to use to then run it and to get the desired output. That's, again, quite impressive. So it's quite interesting. How can you apply this? As I'm always in this purple space, right? I used to do red teaming. Nowadays, I'm in our managed services, so I look after EDRs. And I try to use them better and more and add additional telemetry. It's important that you know, if you have an EDR, which I hope you do, understand what the telemetry gaps are, because there are telemetry gaps. Understand them, know about them. And that doesn't work by calling your vendor and saying, hey, what are your telemetry gaps? So it requires testing, understanding, and it requires some expertise. But I think it's important. Then try figuring out, okay, but how do we, can we actually use AI potentially to speed up some of these efforts? In the talk on Monday, it was a good example. There we actually used it a lot more in a benign way in the demos. We were actually using LLM models to generate detection rules, to say, okay, but if I have a visibility gap, how could I potentially close that? So, very simple. If you know that your adversaries are going to start using AI to become much more effective and efficient, you need to do the same on the blue team side of things. A more autonomous cyber defense systems, that's a big one, right? That would be very nice. I'm not sure yet what it will look like, but I think it's important that we understand, okay, but this is, we're 2024, right? And I noticed that, what was it Sam Altman who said? I think it was Sam Altman, right? Who said the GPT-4 is the worst LLM model we'll all ever work with. So yeah, there's a lot to come, right? So this is very important to understand, okay, but this has implications for a lot of us. The whole security by obscurity, if you will, relying on the fact that your adversary doesn't know certain things, that's a dangerous strategy, I guess. That's it. Excellent. I said excellent.